Welcome to another lesson of transparent physics, and today's topic is acceleration. And acceleration is a pretty heavy topic to lay on you early in your kinematic studies. I consider it to be the most confusing term in introductory kinematics. So I guess if we want to clear things up, there's no better place to be than transparent physics. So acceleration is a word that is not uncommon to hear in everyday conversation, and that's not always a good thing in physics because often the way that they're using it in everyday discussion is different than the way we're going to use it, which is usually a lot more specific in physics class. So for example, when people say to accelerate, generally what they're saying is the object speeding up. As you can see from this Spider-Man comic strip here, in the middle strip, the limousine that Spider-Man's riding on suddenly speeds up, and pretty good physics there. The car speeds up. Spider-Man continues with his initial inertia, so that's good. Good job, Stan Lee. So, but it does mention that acceleration is speeding up, and that is again what 99% of America or the world, depending, I don't know what the word for accelerate is in other languages, but I assume if there is one, that it's probably being used in that way as well. And another example in your car, at least in America, sometimes we refer to our gas pedal as the accelerator. And obviously, again, that connects the idea of acceleration to speeding up. And the issue is that when we are discussing acceleration in physics, it can be more than just speeding up. It can be speeding up, it absolutely can be, but it also can be more than that. And we're going to discuss how that's the case, but that often leads to confusion because we use the term acceleration in a context where people are like, whoa, wait, that's not acceleration. But it actually is, in physics class at least. So in order to successfully discuss acceleration, we're going to need to take a step back and talk about another physics term that we talked about in an earlier video, because that really provides the foundation for understanding acceleration. And if we take a look at the definition of acceleration, it is the rate at which velocity is changing over time. And that term velocity is critical in understanding what we mean when we talk about acceleration. So let's talk briefly about what velocity is. If you didn't have a chance to watch the video, or maybe it's been long enough that you forget about it, we understand that velocity is a vector measurement. A vector measurement is a measurement that includes a magnitude and a direction. And in this case, a magnitude is the speed of the object, how fast it's traveling, and then we also need to include the direction. Is it traveling in the positive or negative direction? Is it traveling north, south, east, west? Is it traveling at 47 degrees? Whatever it is. You need both of those components together in order to have a velocity. So it is speed and direction equals velocity. So when we are talking about a change in velocity, that means there's a couple different ways that we could meet that definition. You could change the speed, and this is really where most people sort of assume acceleration is. And even within that, there's a very specific part of this that people assume, because speed is, again, how fast you're traveling. Changing your speed can actually mean speeding up, obviously, but it can also mean slowing down. So slowing down is technically a change in speed. If you slow down, your velocity is changing. Therefore, you're accelerating, even when you're slowing down. In addition, because velocity includes direction, your direction could be changing. Your direction could be changing even if your speed is constant. So if you're driving around in a circle at a constant speed, that's technically acceleration. So there is a lot of instances where your velocity can be changing and you can be accelerating, but it does not match our assumptions about what acceleration is. We just look at it as that one individual aspect. Acceleration is speeding up, and it really is more than that. So acceleration is also a vector quantity as well. It includes both the magnitude of the rate of change and the direction of the rate of change. We'll talk a little bit more about the direction of the acceleration as well. That complicates things a smidge further. So now that we've defined acceleration, let's talk about how we go about calculating it. A little bit of a qualifier on this discussion: acceleration can mean to speed up, to slow down, or to change direction. This video is only going to be talking about the speeding up or slowing down aspect of things. Changing directions is a really cool topic. There's lots of neat physics to talk about with that, but most physics classes will save that until you get into a section called uniform circular motion, because there's some new complexities that we need to focus on. So for now, we're at the beginning of our physics journey, and we will just focus on things speeding up or slowing down for this video. The acceleration, as previously hinted at, is change in velocity over change in time. And so that's the equation. It's not too crazy, just it's literally velocity divided by time. You take your final velocity minus your initial velocity divided by time to get your acceleration. You can get some extra complexities in there depending on the direction of the velocity, if it's a positive velocity or a negative velocity, for instance. But it's not the worst equation you're going to see in physics this year. So now that we have the equation for acceleration down, we come to another point of confusion when kids are studying acceleration, and it's the idea of square seconds. When we talk about acceleration, the units are meters per second squared. So that becomes a little hard to figure out what it means, because let's say we have 3 meters per second squared. What exactly is that? 3 meters per square second? I don't know what a square second is. I don't know how you measure it. I don't know what that means. Students who take physics don't understand what a square second is, and I don't blame them, because I don't know what it is either. It doesn't mean anything. We don't have a device that you can order from a scientific catalog that measures square seconds. I don't even know what conceptually a square second would represent. The reason we have square seconds in the first place is really just more of a convenience than anything else, and I use the term convenience in air quotes there. When we take a look at the equation for acceleration, which is change in velocity over change in time, if we break that equation up into the units that would be represented by that, we can see that velocity is meters per second, time is seconds. So when you literally read the fraction that says the units for acceleration, it's meters per second over per second. So that is meters per second per second. I don't think it's that bad. Again, it takes a little bit of time. That pause is what really makes it happen. You just kind of gotta let it sit for a second and then sort of continue. Somebody, sometime, somewhere decided that was took too long. We got to speed things up. So they said, hey, I've taken math class, and I know that a meter per second is the same thing as a meter per second times 1 over seconds, because dividing by something is the same as multiplying by the reciprocal. Seconds times seconds, you can combine together in the denominator. M times 1 just becomes M. And then you've got meters on the top, and seconds times seconds on the bottom, so you have seconds squared. Ta-da! So acceleration is now meters per second squared. Yes, I do concede that's a faster term to say, but in the benefit of gaining that, one syllable reduction or whatever it is, I think we've totally, if you want a fancy word, obfuscated the meaning of acceleration. To obfuscate means to make harder to understand. It really is simply meters per second, but we use the term meters per second squared. So whenever you see seconds squared, just recognize that is just people trying to save you a little bit of time. But that does come at a cost. Okay, we have enough information to start putting some stuff together and talking about acceleration in practice. Let's imagine that we have a ball that has an initial velocity of 0 meters per second and an acceleration of plus 2 meters per second squared. Remembering that acceleration tells you the rate at which velocity changes, or said another way, it tells you how the velocity changes each second. A change in velocity of plus 2 meters per second every second, plus 2 meters per second is the same as saying plus 2 meters per second squared. So every second, plus 2 meters per second squared is going to change your velocity by a value of plus 2 meters per second. What does that look like in practice? Time of 0 meters per second, and then you can see every second the speed increases. well, the speed, well, yeah, I guess that's fair to say. The speed increases by 2 meters per second. The direction is always in the positive direction. So the object is speeding up in the positive direction with a constant rate. Another example, let's say a ball has an initial velocity of positive 18 meters per second and an acceleration of negative 3 meters per second squared. And before I continue with this, let me just point out one thing real quick. The idea that in front of the acceleration we're talking about right now is a negative sign. It's negative 3 meters per second squared. The first acceleration we talked about had a positive sign in front of it. Acceleration is a vector quantity, so it does need a direction. For introductory physics, early in the year, you're probably going to be able to get away with just saying plus or minus for the direction. And again, that's associated with the fact that your motions are going to be one-dimensional. You're going to be walking forward or walking backwards. There's going to be an elevator moving up or moving down, things like that. So a plus and a minus, more than sufficient for us to start things off with. So an acceleration of minus 3 meters per second squared means that again, that minus 3 meters per second squared literally means minus 3 meters per second. So every second we would expect to see our velocity change by minus 3. What does that look like in practice? Well, let's take a look. 0 seconds, 18 meters per second, 1 second, 15 meters per second, etc., etc. And you can see that the object is slowing down. In this case, the negative acceleration means the object's going to end up with a lower velocity than it did to start. So let's address the elephant in the room. We talked about an object slowing down. The temptation is to call that a deceleration. And I have to admit, this is a bit of a personal crusade of mine. I'm going to get up on my soapbox here for a minute. When we talk about the prefix DE means removal or reversal. It means to like undo something or get rid of something, to do the opposite of it. So if you're deflating a balloon, you're uninflating it. If you're decomposing, you're not putting it together. So what does that mean when applied to the word acceleration? Acceleration in a physics context means a change in velocity. So does it mean that you're not changing the velocity, or does it mean you're getting rid of the velocity that you changed? It gets messy, but it only gets messy if you understand the real definition of physics. If you're like 99% of the world and assume that acceleration means only to speed up, well, yeah, then you're okay. Because if acceleration only means speed up, then deceleration means slow down, and that's great. Bob's your uncle. We move on. The problem is that that's not what acceleration means in physics class. So I really dislike the term decelerate because it relies on an incorrect assumption about what accelerate means. And we want to try to avoid that. But even physics textbooks, I see them use the word decelerate. But you know, it's their book. I guess they can do what they want to. But I try super hard not to use the word decelerate, because again, it assumes that the word accelerate means only a certain thing when acceleration means so much more. Okay, so we can't say the word deceleration anymore, but in the previous slide, we did talk about the idea of a negative acceleration slowing things down. So when I tell my students, well, you can't say decelerate anymore, they're like, well, the negative acceleration works right. Well, sometimes. I'm sorry, kids. There's a lot of rain on this parade this time. I'm gonna pause for a sip of tea. All right, we're gonna get back to this. So, negative acceleration sometimes means slowing down. Just like an example we saw earlier, if an object has a positive velocity and a negative acceleration, we will see the magnitude of the velocity, aka the speed, reduced over time. So an object that's moving at 12 meters per second, 4 seconds later is moving at 4 meters per second. That is slower than it was before. Positive velocity, negative acceleration. Every second, the velocity changes by negative 2 meters per second. That's going to slow you down. Absolutely. But remember, velocity is a vector quantity, so it can be, in this case, positive or negative. What if instead of starting with a positive velocity, it started with a negative velocity? And again, a negative velocity doesn't mean it's like evil or bad, or it just means it's the other way. So if positive is up, negative is down. if positive is to the right and negative is to the left. That's all it is. It's just the other way. That's all we're saying. So let's say an object has an initial velocity that is negative, and it has an acceleration that's negative. It's the exact same acceleration from the previous example, but now this time it's applied to a negative velocity instead. The acceleration still means the exact same thing. Every second, the velocity is going to change by negative 2 meters per second. But if it starts off as a negative value, what we see is that every second, changing it by a negative 2 meters per second, said another way, you're adding a negative 2 every time. Adding a negative 2 to 12 is basically subtracting 2 from it, so you go positive 12 to positive 10. Adding a negative 2 to negative 12 makes it a negative 14. You're making it more negative. So a negative 12 meters per second becomes a negative 14. Negative 14 becomes negative 16. That is a change of negative 2 meters per second every second. So you can see here, and again, it gets a little bit confusing when you're looking at negative 20 meters per second. People look at negative 20 meters per second and want to say, well, that's less than negative 12. Break it up into its two parts. Negative 20 meters per second. The 20 meters per second is the speed, and the negative is the direction. If it makes you feel better, maybe negative is west and positive is east. So if you're driving west I won't say negative, if you're driving west at 12 meters per second, and then you're driving west at 20 meters per second, you're driving faster than you were before. The speed tells you the magnitude of the motion. The direction tells you which direction that motion is headed. So you are moving faster after 4 seconds if you've got a negative velocity and a negative acceleration. So it is definitely a point of confusion that sometimes negative acceleration can speed you up and sometimes negative acceleration can slow you down. All right, let's use an organizational tool to help us get our heads around how accelerations and velocities partner up depending on the circumstances. Here's our grid, positive velocity and negative velocity. Remember, negative velocity just means you're moving in a different direction than you were for the positive velocity. If your positive velocity means east is positive, then negative is west. If positive velocity means up, then negative velocity means down. That's all it is. Nothing's wrong with negative velocity. It's just different. It's just different. So if we take a look at a combination of a positive velocity and a positive acceleration, we can see that the speed is increasing. Now, speed is the magnitude of your velocity. So in this case, if you take a look at a minute and you look at the numbers, you would see that the acceleration is ... It is positive 2 meters per second squared. That means that every second the speed is changing by plus 2 meters per second. And you're going to end up faster when the time is done. And again, this is what a majority of people think of when they think of acceleration. Oh, but acceleration is so much more. Let's say we've got a positive velocity and a negative acceleration. So in this case, we started with the same positive velocity, plus 10 meters per second. In this case, if you take a look at the numbers, you can see that the acceleration has switched to negative 2 meters per second. And by changing the velocity by negative 2 meters per second every second, the magnitude of the speed is decreasing. So we're going from plus 10 to plus 8 to plus 6 to plus 4, and that's definitely an object that's slowing down. Positive velocities generally are pretty easy to interpret in this context. When we get to negative velocities, there's a challenge. Because, again, we have this connotation about what negative velocity means, and sometimes that gets in the way of actually understanding what's happening. A negative velocity and a positive acceleration means that the object's traveling, say, to the west, but the acceleration is directed towards the east. And so we see that the velocity might start with negative 10 meters per second. But in this case, if the acceleration is plus 2 meters per second squared, you can see that plus 2 changes the velocity such that the speed is decreasing. Negative 10 plus 2 is negative 8. Negative 8 plus 2 is negative 6. So the magnitude of the motion, the speed, is decreasing over time. So it is slowing down, but it's slowing down traveling in the negative direction. So in our example, it would be west. You're just slowing down while driving west. That's all that means. Counterintuitive, yes, but if you just let the math guide you, I think it helps out. And then the last one, negative velocity and negative acceleration. That means you're driving west and accelerating in the westward direction. So your velocity is negative 10 meters per second. Your velocity changes by negative 2 meters per second. So you go from negative 10 to negative 12. Negative 10 plus a negative 2 is negative 12. Negative 12 plus a negative 2 is negative 14. So by the time you're done at 4 seconds, your speed has increased. A negative 18 meters per second is faster than negative 10 meters per second. A common mistake my students make is they think that negative 18 is less than negative 10. And again, in some context, sure it is, but not this one. Here, we're talking about the magnitude of the motion. So covering 18 meters in a second is more than covering 10 meters in a second. You're just traveling in the other direction. That's all it is. So when we take a look at this overall, again, it can be confusing, especially when you're starting with a negative velocity. But if you just let the numbers guide you, it'll tell you what's happening, and you just have to have faith in yourself that you'll interpret it correctly. When velocity and acceleration are in the same direction, whether that's positive and negative, your speed is going to increase. When velocity and acceleration are acting against each other, your speed is going to decrease, regardless of whether your velocity is positive or negative at the time. I like to use the expression that when you work together, things speed up, in the idea that when your velocity and your acceleration are in the same direction, you will end up with a higher speed than you did before. And that's a positive way to think of things anyway. All right, we made it to the end of the video, and this was a tough one, I'm not going to lie. Let's review all the soul-crushing things that we discovered about acceleration in the course of this video. First of all, most people come into this video with an understanding of what acceleration is, and then they get the rug pulled out from under them because acceleration means exactly the opposite, or it could mean exactly the opposite of what they think. When we assume acceleration means only speeding up, you're in for a problem with physics, because physics is like, nope, it could mean slowing down or changing direction. So that's a tough pill to swallow. Number two, the units don't help out at all. The units for acceleration are technically meters per second, but somebody decided in the role of expediency that we should use instead meters per second squared. And then you get to square seconds. Square seconds, what does it mean? Square seconds doesn't mean anything, so strike two. Then we have the term decelerate. Well, again, if acceleration doesn't always mean speeding up, then deceleration, if deceleration only means slowing down, then what does that mean when acceleration can mean a lot of different things? Toss deceleration away. We can't use that term anymore. Strike three. Then maybe you're floating in the water, you grab onto the life preserver, you're like, hey, well, at least we have negative acceleration. Negative acceleration is our new slowing down. Nope, pull the life preserver away. Negative acceleration could mean speeding up or slowing down. It just depends on the context of where you are. So strike four. You can't even get that in baseball, but you can get it in physics. So long story short, acceleration is a challenging topic. It's filled with things that don't make sense at first glance, or things that you think make sense at first glance, and then you realize they don't when you look at it further. It'll get better. It will get better. You will understand it. But if you're confused by acceleration to start, you're in very good company. Does someone you know have trouble understanding acceleration? If so, consider liking this video, commenting below, or subscribing to the channel so that YouTube's algorithms can spread this video far and wide, and someday we may find a cure for I don't understand acceleration-itis. And as always, thanks for watching. Hopefully we've made physics a little clearer for you in this episode of Transparent Physics.